Hello students, let us start our discussion about refraction through curved surfaces. Now let us take our first topic, refraction through convex surfaces. So this is a convex surface which bifurcates two different media, media 1 and media 2, in which we can assume that first one is rarer and second one is denser. You can choose second one is rarer and first one is denser. You are free to choose. Okay, so for simplicity, let us, the first media is rarer and second one is the denser. So if we assume that if there is a point object placed on the principal axis of this curved surface, then how the image of this point object will formed in the denser media. So this curved surface which bifurcates the rarer medium to the denser medium, this forms the image of this point object. Let us draw an incident ray from this point object to the curved surface, and you know what will happen. Suppose that this is the center of curvature of this curved surface. Then if we join this center of curvature to this incident point, then this line will treated as what? This is the normal. Okay, so this angle is equal to the angle of incidence. Now as we know that when light ray goes from rarer medium to denser medium, then it refracted towards the normal. So the final light rays goes through in this direction and meets the principal axis at point I. Okay, so what the angle makes this line by the normal? This angle is taken as R. This is known as angle of refraction. This is angle of incidence, and this is the point of incidence. Okay, we want to deduce an expression between the relationship of the radius of curvature R, the image distance and the object distance. Okay, so let us assume that the refractive index of the first media is mu1 and the absolute refractive index of the second media is mu2. So if we want to derive an expression between the image distance, object distance and the radius of curvature, so we will take this point, suppose that this point is Q and this is P. So if we take this point Q near at P, then angle I can be taken as very small and R will also small. As we know that for a small angle, sin I will be treated as nearly equal to I in radian. For a small I and R, sin I nearly equal to I in radian and sin R is nearly equal to R in radian. Okay. Now suppose the incident ray, refracted ray and normal, incident ray, refracted ray and normal makes alpha, beta and gamma, alpha, beta and gamma radian respectively to principal axis. Okay, now if we apply Snell's law at this point of incidence Q, then we get, what will we have? Mu1 sine I, applying Snell's law at refraction, at refracting point Q. Mu1 sine of I is equal to mu2 sine of R. Now, as we have seen that for a small value of I and R, sin I can be taken as nearly equal to I, sin R is also taken as nearly equal to R. So this can be written as mu1 I is equal to mu2 R. This equation is 1. Now let us find the value of I and R in terms of alpha, beta and gamma. So in triangle QOC, if we apply exterior angle theorem from exterior angle theorem, then we find out this angle I is equal to alpha plus gamma. I is equal to alpha plus gamma, and from QCI we can find out the value gamma is equal to R plus beta. Gamma is equal to R plus beta, which after rearranging we find out R is equal to gamma minus beta. This is the third. So if we put the value of I and R from second and third, then from first we get, from first, mu1 whole into alpha plus gamma is equal to mu2 into gamma minus beta. Okay, so after rearranging we get mu1 alpha plus mu1 gamma is equal to mu2 gamma minus mu2 beta. So if we take gamma one side, then we get mu1 alpha plus mu2 beta is equal to mu2 minus mu1 whole into gamma. Means this term is taken towards this side and this one is taken towards this side. Now, so if we put the value of alpha, beta and gamma from this figure, then we get, now if we take this QP as the arc length, then if we assume this alpha is in radian, then angle in radian can be expressed as the ratio of the arc length to the radius. So this alpha can be expressed as QP divided by OP, means QP by this distance. This is the object, so this distance, this is opposite to the incident ray, so this can be taken as negative sign U. Similarly, what will be the value of beta? So beta can be taken as QP by PI. QP by PI is equal to QP by this PI is equal to plus V. This is the image distance. This is the image distance, because this one direction is taken in the direction of incidence, so the sign of V is taken as positive and sign of U is taken as negative. Now similarly, gamma is equal to QP by PC. QP by PC. So this will be equal to QP by plus R. Okay, so if we put all these values of alpha, beta and gamma in equation number 4, then we get what? Then we get mu1 into alpha. Alpha means QP by minus U. Here few students will confuse why we'll take QP as arc length. Then if the point Q is taken nearly just at point P, then this QP is taken as arc length. Okay, in few books this is mentioned by this type: take a perpendicular on the principal axis point M, and this point M is considered just near equal to P. Then finally we put the distance OM just equal to OP, and the distance MI just equal to PI. So initially we have mentioned this. Okay, so now let us put the value of alpha, beta, gamma from here to in this equation. We get mu1 into alpha means QP by minus U, QP by minus U, and plus mu2 into beta means QP by plus V is equal to mu2 minus mu1, mu2 minus mu1, and gamma means QP by plus R, QP by plus R. Okay, so as we have seen that QP is common in each term, so this will be cancelled because taking outside from both term. So we get what? Mu1 by minus U plus mu2 by V is equal to mu2 minus mu1 by R. So this term is have a negative sign, so we put this term as a first term. Mu2 by V minus of mu1 by U is equal to mu2 minus mu1 by R. This is the important relation between the object distance, image distance, and the radius of curvature, which we have derived from the help of this figure or geometrical configuration. Okay, now let us solve different numerical problems and also derive an expression for the transverse magnification, because we have chosen this object as a point object. So if we choose a finite size object, then what will be the magnification produced by such spherical curved surfaces? Okay, so what will be the formula for the magnification? Let us derive that. Let us derive an expression for the formula of transverse magnification. Transverse magnification. Now, as we know that from the equation of mirror, 1 by V plus 1 by U is equal to 1 by F. We have find out the formula for the magnification is I by O, the size of the image to the size of object, that is equal to minus of V by U. So if we compare this formula with the help of this, then we get if we write this formula in the term of this formula, then from mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. This can be rewritten as 1 by V by mu2 and minus 1 by U by mu1. So in this this is a positive sign, so if we mention this, then we get what? This have a negative sign. Okay, so this sign can be taken as at this position. So and here we get 1 by R upon mu2 minus mu1. Okay, so if we compare with the help of this, then we have replaced this V by mu2 and U by minus of U by mu2 mu1, and this F is by R whole into mu2 minus mu1. So if we write the formula for magnification, then we get what? M is equal to I by O, height of image to the height of object, that is equal to minus v by u. So what is the value of v? Put this sign minus. What is the value of v? V means v by mu 2. V by mu 2 divided by what is the value of u? This is minus of u by mu 1. So if we solve this, then we get m is equal to mu 1 by mu 2 and this v by u. So this is the formula for transverse magnification produced by this curved surfaces when light ray go from one medium to the other medium. Always we have seen that when we take either different type of media, means rarer media at this side and denser media at this side, then we again get this type of formula, mu 2 by v minus mu 1 by u is equal to mu 2 minus mu 1 divided by r. Okay, and if we take a concave surface for refraction like this, then again we get same type of formula, mu 2 by v minus mu 1 by u is equal to mu 2 minus mu 1 by r. So this is a universal formula. You can put the value of u, v and r with the sign convention and solve different types of numerical problems which is based on either convex shaped curved surfaces or concave shaped curved surfaces. Okay, we will solve different types of numerical problem in our next video on the basis of this formula and this formula of transverse magnification. Till now, take care. Thank you.